My dear students, in my previous video, we have seen the expansions of some functions using Maclaurin series. We have expanded the trigonometric function tan x and arc tan x and log 1 minus x and so on. These functions have been expanded using Maclaurin series we have seen in our previous video. Now in this video, I am going to introduce indeterminate forms. To evaluate certain limits, we can come across some indeterminate forms. While evaluating a limit, for example, limit x tends to 0 sin x by x. For this function, if you apply the limit x tends to 0, you will get in the numerator, you get sin 0 by denominator x. If it tends to x tends to 0, it becomes 0. You know sin 0 is 0 and another 0 in the denominator. So it is of the form 0 by 0. This form 0 by 0 cannot be simplified further and it should not give any answer. It is an indeterminate form. 0 by 0 is called indeterminate form. There are some indeterminate forms in mathematics. While evaluating some certain limits, you come across that indeterminate forms. What are the indeterminate forms? Some indeterminate forms are zero by zero, infinity by infinity, 0 into infinity, infinity minus infinity, 1 power infinity, 0 power 0, infinity power 0, and so on, like that. These forms are called indeterminate forms. 0 by 0 is an indeterminate form. Infinity by infinity is not a simplifiable one, it is infinity by infinity itself, it is called indeterminate form. 0 into infinity, it cannot simplify. Infinity minus infinity is not 0. It cannot be simplified. It is an indeterminate form. 1 power infinity is not 1, but it is an indeterminate form. 0 power 0, infinity power 0. We know anything power 0 is 1, so I can say infinity power 0 is 1. We can say infinity power 0 is 1, is it not? It is an indeterminate form. So these forms are called indeterminate forms. If you evaluate certain limits of this given function, you can come across this indeterminate form. In that case, you can use Hopital's rule. So if you come across a limit of indeterminate form, you apply Hopital's rule to evaluate that limit. What is Hopital's rule? I am going to explain now. These are the indeterminate forms to take down. And next I am going to explain what is Hopital's rule. See, while evaluating the limit x tends to 0, sin x by x is sin 0 by 0. Sin 0, 0 you know. So 0 by 0, it is an indeterminate form. So for this case, we have to apply, we have to use Hopital's rule. What is Hopital's rule? Limit is of a function, problem is of the form numerator and denominator. Limit some x tends to a, f of x by g of x. Numerator is a function of x and denominator is another function of x. If you apply the limit, you will get indeterminate form. If you get indeterminate form after applying the limit, in this case it is of the form, it is numerator and denominator form. Numerator is a form of function of x, denominator is also a function of x. If you apply the limit, you will get in the indeterminate form. In this case, you have to use Hopital's rule. Hopital's rule states that if you applying the limit, if you find indeterminate form, you have to differentiate numerator and denominator separately, not by applying, what is that, quotient rule. Just by Hopital's rule, limit x tends to a, numerator should be differentiated separately and denominator should be differentiated separately. F dash of x by g dash of x. Now you apply the limit x tends to a, you will get the answer. You will get some answer for the problem. Even then, if you again, after differentiating, you will get an indeterminate form. You once again you have to differentiate by Hopital's rule. You have to once again differentiate f double dash of x by g double dash of x, and you apply the limit. In this case, you can get the answer. So like that, Hopital's rule states that if you find an indeterminate form after applying the limit, you will differentiate the numerator separately and the denominator function separately and apply the limit. You will get the answer. If not, again you will get indeterminate form. You further differentiate the numerator again and the denominator function again you have to differentiate. You will get the answer. This is Hopital's rule. Now for our function, in this problem, limit x tends to x tends to 0. X tends to 0 or sin x by x. After giving the limit, you will get sin 0 by 0. This is 0 by 0, you will get indeterminate form. By Hopital's rule, you have to differentiate the numerator function and the denominator function separately. Derivative of sin x is, cos x. By derivative of x is 1. Differentiation of x is 1. Differentiation of sin x is cos x. Now you apply the limit x tends to 0. You will get cos 0 by 1. Cos 0 is 1. 1 by 1. So your answer is 1. The indeterminate form, if you apply the limit directly, you will get the indeterminate form. By applying Hopital's rule, you will get the answer 1 for the limit sin x tends to limit x tends to 0, sin x by x is 1. That's all about the answer. So this is Hopital's rule. Like that, if you differentiate the numerator function and the denominator function separately, applying the limit, you will get the answer. You should not use quotient rule, remember. See, this is called Hopital's rule. We are going to solve few more problems for the indeterminate problems, indeterminate forms using Hopital's rule. We will see, that is exercise 7. What is exercise problem? In your textbook 7.5, exercise 7.5, you will see. So, indeterminate forms I have given and what is Hopital's rule I explained. Now I am going to solve the problems in the exercise 7.5. Exercise 7.5. First problem, limit x tends to 0, 1 minus cos x by x square. Evaluate limit x tends to 0, 1 minus cos x by x square. If you apply the limit directly, you will get 1 minus cos 0 by 0 square is 0. Cos 0 is 1. 1 minus 1 by 0. 1 minus 1 is 0. 0 by 0, it is indeterminate form. If you apply the limit straight away to this problem, 1 minus cos 0 is 1. So 1 minus 1 is 0. 0 by x is 0. Limit x is 0. 0 square is 0. 0 by 0, you will get an indeterminate form. By Hopital's rule, limit x tends to 0, differentiating the numerator, derivative of 1 is 0, minus of derivative of cos x is minus sin x, by derivative of x square is 2x. Again, you simplifying, limit x tends to 0, minus or minus plus sin x by 2x. Now you apply the limit x tends to 0, it is sin 0 by 2 into 0, 0, it's again 0 by 0, again indeterminate form will get. Again it is in indeterminate form. So further by Hopital's rule, limit x tends to 0, derivative of sin x is cos x by 2x and the derivative of x is 1, 1 into 2 is 2 because derivative of x is 1, 1 into 2. Now you apply the limit cos 0 by 2. Cos 0 is 1. Cos 0 is 1, you know, 1 by 2. So your answer is 1 by 2 for this problem. For this problem, after applying Hopital's rule 2 times, you will get the answer. That's all about the problem. Just applying limit, you will get indeterminate form. By Hopital's rule, differentiating numerator and denominator separately, again you will get the indeterminate form. Further you apply the Hopital's rule, you will get the answer. That's all about the problem 1 in the exercise. Next, problem 2. Limit x tends to infinity. Second problem. So take down this problem. It is very simple. Next, second problem in the exercise. You will see. Second problem. Evaluate limit x tends to infinity 2x square minus 3. Limit x tends to infinity 2x square minus 3 by x square minus 5x plus 3. X square minus 5x plus 3. You apply the limit x tends to infinity, numerator infinity, denominator by infinity, it is of the form infinity by infinity. If you apply the limit x tends to infinity directly, 2 into infinity is infinity minus 3 is infinity, infinity minus infinity and plus 3, again it is an infinity, indeterminate forms. Okay, in this case, before Hopital's rule, one more idea we have, just you divide x square, both numerator and denominator by x square, 2 minus 3 by x square in the denominator, 1 minus 5 by x plus 3 by x square. If you apply the limit, before applying the limit, you divide entire term in the numerator by x square, 2x square by x square is 2 minus 3 by x square. Denominator x square by x square is 1 minus 5x by x square is 5 by x plus 3 by x square. Like that you divide numerator and denominator by x square. Now you apply the limit. In this case 3 by infinity 0, 2 minus 0 divided by 1 minus 5 by infinity, 1 by infinity is 0. This is plus 3 by infinity is also 0. So you will get 2 minus 0 is 2 by 1. That is equal to 2. This is your answer for this problem. So the same problem you can use Hopital's rule also. One idea is by dividing x square both numerator and denominator. Now by Hopital's rule, differentiation of numerator and denominator separately, limit x tends to infinity, derivative of x square is 4x, 2x square is 4x minus constant derivative is 0, by denominator x square is 2x, minus derivative of 5x is 5 into 1, derivative of x is 1, 1 into 5 is 5 plus constant 0. Now you apply the limit and limit x tends to infinity is again infinity by infinity. It is again an indeterminate form. Again by Hopital's rule, limit x tends to infinity, 4x derivative is 4, by 2x derivative is 2. There is no x term here. So we need not apply the limit x tends to, it is a constant, 4 by 2 is 2. So it is also, applying Hopital's rule also will get the answer, the same answer. So by taking x square numerator and denominator outside you will get the answer, or otherwise by Hopital rule also you will get the same answer. It is another problem in the exercise 7.5. Okay. Next problem 3. Limit x tends to infinity x by log x. Next sum. Problem number 3. Evaluate limit x tends to infinity x by log x. X by log x. So in this problem, if you apply limit x tends to infinity by log infinity is infinity, therefore it is of the form, indeterminate form, infinity by infinity you will get. If you apply the limit directly, x tends to infinity, numerator is infinity and denominator is also log of infinity is infinity. So it is of the form, indeterminate form, infinity by infinity. Therefore by Hopital's rule, limit x tends to infinity, derivative of x is numerator 1, by denominator derivative of log x is 1 by x. Derivative of log x is 1 by x. Now you apply the limit 1 minus 1 by infinity, x tends to infinity, 1 by infinity is 0, 1 by 0, 1 by 0 is infinity. So the problem for this, answer for this limit x tends to infinity, x by log x is, answer is infinity. It is the answer for the given problem. That's all about this exercise. And next we will continue the remaining exercises in the next video. Okay, you remember what is indeterminate forms and how to apply Hopital's rule we have seen. So you study this video carefully and we will continue the problems in the next video. Thank you.